Welcome back to the Deep Dive. Today, we're going to be taking a deep dive into some research about large language models, or LLMs.
Okay.
You know how some of these AI models can be a little chatty when they're solving problems?
Yeah.
Turns out that this can actually slow them down
Right.
and cost more in terms of computing power.
Uh-huh.
So the paper that we're looking at today
You're right.
is called Token Budget-Aware LLM Reasoning.
Interesting.
And the authors found a way to guide these LLMs
Hmm.
to use their resources more wisely
Okay.
without sacrificing accuracy.
I see.
They call this concept token budget.
Okay.
It's like giving the LLM a set number of thinking points to use for each question.
Interesting.
And the research shows that this can lead to much shorter answers
Okay.
while still maintaining the same level of accuracy.
Cool.
There's this one example in the paper that really stood out to me.
Yeah.
An LLM was asked a math problem,
Hmm.
and without a budget,
Okay.
it used a whopping 258 tokens to answer.
Wow.
But with a budget of just 50 tokens,
Okay.
it still got the answer right using only 86 tokens.
That's impressive.
It's like telling someone to write a 10-word summary, and they end up writing a whole essay.
Yeah, that's a big difference.
Interestingly, though,
Mm-hmm.
giving a very small budget can sometimes
Yeah.
make the LLM use even more tokens.
Oh, really?
It's almost as if it panics and overcompensates.
Interesting.
It seems counterintuitive, right?
Yeah.
It's a phenomenon called token elasticity,
Okay.
and it suggests that LLMs are associating longer responses with better performance.
That makes sense, I guess.
Maybe it's because they're trained on data sets where humans prefer more comprehensive answers.
Could be.
So how do we work around this token elasticity issue?
Well, the researchers developed a framework called TAIL,
Okay.
Token Budget-Aware LLM Reasoning,
Okay.
and it dynamically figures out the best token budget for a given question.
So TAIL is like the LLM's financial advisor, making sure it spends its tokens wisely.
It has two approaches. In one approach, the LLM estimates its own budget.
It's like it's becoming self-aware of its own limitations.
Right. And if the LLM has trouble estimating, there's a second LLM that's trained specifically to predict the right budget.
It's like having a specialist assistant to manage the reasoning process.
You could say that.
The paper also mentions fine-tuning an LLM to be more token conscious.
Essentially, they're training the LLM to be inherently more concise in its responses while preserving accuracy.
So like instilling a sense of frugality in the LLM,
Right.
encouraging it to use its tokens wisely.
Yes.
This is all sounding really promising.
Yeah.
I'm eager to see where this research leads and what other clever ways they find to optimize these LLMs.
Me too.
Now let's dive into some of the specifics of how LLMs reason.
Okay.
One approach you'll see is chain of thought reasoning, or COT for short.
Mm-hmm.
COT, what's that all about?
It's how the LLM breaks down a problem into smaller steps,
Oh.
just like a human would.
Okay.
Think of it as showing your work in a math problem. It's great for transparency, but can be pretty verbose.
And that's where the token budget concept comes in, right?
Yes,
To rein in that verbosity.
exactly.
The paper shows how a COT prompt leads to a much longer answer
Uh-huh.
than a direct answer.
Right.
It's like a student writing a long essay when a short paragraph would suffice.
I see what you mean.
And this brings us back to figure 2 in the paper,
Right.
which visually illustrates that token elasticity phenomena we talked about.
Mm-hmm.
It shows how the actual token cost can go up
Yeah.
when the budget is reduced too much.
Interesting.
So it's almost like there's a sweet spot for the budget,
I see.
a range where the LLM performs most efficiently.
Right.
Finding that sweet spot is what their algorithms are designed to do.
Exactly.
These figures really help to grasp the concept.
Yeah.
It's not just theoretical. They have concrete examples to back it up.
I agree.
What about figure 7? That one seemed to lay out the whole TAIL workflow.
Figure 7 shows how TAIL estimates the budget,
Mhm.
constructs the prompt, and guides the LLM to generate the final answer.
Okay.
It really brings the process to life.
The paper also includes several tables with a lot of quantitative data, right?
Yes, those tables really drill down into the details.
Okay.
Table 2 compares TAIL with other prompting methods and shows how it consistently outperforms them in terms of token usage and cost, while still being just as accurate.
That sounds promising.
And Table 3 highlights its versatility by showing how well it works across 3 different LLMs,
Okay.
Yi Lightning,
Mm-hmm.
GPT-4 Mini, and GPT-4o.
Okay.
Those results demonstrate that TAIL is a robust framework with wide applicability.
Yeah.
Its benefits aren't limited to specific models or tasks.
It's fascinating how this research has unearth these hidden efficiencies
Yeah.
within LLMs.
It really is a fascinating insight into how these models work and how we can make them more efficient. And they didn't stop there.
Yeah.
They went a step further
Oh,
and tried to find the optimal
the
budget.
optimal budget.
Yeah, for different situations.
Oh, interesting. Uh, I imagine that's not always easy to figure out.
You're right. They actually had to develop algorithms
Okay.
to find that sweet spot.
Uh-huh.
They observed this thing called token elasticity,
Okay.
where reducing the budget too much can actually make the LLM use more tokens.
So finding the right balance is crucial.
Yes.
Not too many tokens,
Right.
but not too few either.
That's the key.
Okay.
They developed two approaches for finding this optimal budget.
Right.
The first one involves a kind of search process
Okay.
to find the minimum number of tokens needed.
Okay. So that makes sense. Start with the minimum and see if it works.
The problem is that minimum number isn't always the most efficient.
Oh, okay.
Sometimes a slightly larger budget ends up using fewer tokens overall.
Interesting.
That's where the second, more sophisticated approach comes in.
So that's the token elasticity-based method you mentioned.
Right.
Okay.
It takes into account that sometimes giving the LLM a bit more breathing room leads to better results.
So it's like finding that perfect balance
Yeah.
between conciseness and accuracy.
It's a little mind-boggling to think that we're
Yeah.
talking about fine-tuning the thinking process of an AI, isn't it?
It really is, and the researchers were very thorough.
Yes.
They provided really detailed descriptions of their algorithms,
Mm.
highlighting just how much effort went into finding the best solutions.
Yes, their dedication is impressive.
So let's talk about some of the visuals in the paper.
Okay.
I remember seeing a figure that showed a dramatic difference
Uh-huh.
in token usage between different approaches.
Yes, figure 1.
Okay.
It shows the contrast between directly answering a question
Okay.
using traditional chain of thought reasoning
Okay.
and then chain of thought with a token budget.
Okay, the example they used was a simple calculation of total time spent on a series of tasks, right?
The traditional chain of thought approach
Okay.
used a whopping 258 tokens
Oh,
to explain every step of the process.
okay.
But with a budget of only 50 tokens, the LLM still got the answer right using just 86 tokens.
Wow, that's quite a significant reduction.
And then there's figure 2,
Yeah.
which visually illustrates that token elasticity phenomenon we talked about.
Okay.
It shows how the actual token cost can go up
Up, okay.
when the budget is reduced too much.
So it's almost like there's a sweet spot for the budget,
Yeah,
a range where the LLM performs most efficiently.
exactly. Finding that sweet spot is what their algorithms are designed to do.
These figures really help to grasp the concept.
Yes.
It's not just theoretical.
Mm,
They have concrete examples to back it up.
I agree.
What about figure 7?
Okay.
That one seemed to lay out the whole tail workflow.
Figure 7 shows how Tail estimates the budget,
Okay.
constructs the prompt,
Mm.
and guides the LLM to generate the final answer.
So really brings the process to life.
It does.
Okay. The paper also includes several tables with a lot of quantitative data, right?
Yes, those tables really drill down into the
Okay.
details. Table 2 compares Tail with other prompting methods
Uh-huh.
and shows how it consistently outperforms them in terms of token usage and cost
Okay.
while still being just as accurate.
And table 3
Yes.
highlights its versatility
Yes.
by showing how well it works across 3 different LLMs.
3 different LLMs, Yai Lightning,
Okay.
GPT-4o Mini,
Yeah.
and GPT-4o.
Okay, so those results demonstrate that Tail is a robust framework with wide applicability.
Yes.
Okay, its benefits aren't limited to specific models or tasks.
Right. It's fascinating how this research has unearthed these hidden efficiencies within LLMs. Yeah, it really is a fascinating insight into how these models work and how we can make them more efficient.
This research goes beyond just saving money or computing power, though, right?
Absolutely.
Okay.
Think about the broader impact.
Hmm.
What if we could make LLMs accessible to organizations or individuals with limited resources?
That would be incredible.
Yeah.
It could democratize access to these powerful AI tools,
Yeah.
opening up a world of possibilities
Exactly.
for education,
Mhm.
research, and innovation.
That's the potential we're talking about.
Okay.
And it all comes back to this idea of finding and exploiting these efficiencies
Yeah.
and how these models operate.
It's like we're starting to understand the language of AI, learning how to communicate with it in a way that maximizes its potential.
It's like we're giving it a set of guidelines,
Okay.
a framework for thinking effectively.
This token budget concept feels almost philosophical, doesn't it?
It does.
Are we, in a way, teaching AI to think more like humans?
It's an interesting thought.
Uh-huh.
Humans have limited cognitive resources, so we've evolved to think efficiently.
Okay.
Perhaps these constraints are a step towards AI
Hmm.
that exhibits more human-like reasoning patterns.
It's a fascinating concept to consider.
It
It
is.
feels like we're on the cusp of something truly groundbreaking.
It's an exciting time to
Yeah.
be involved in AI research.
Yeah.
The pace of innovation is incredible.
This paper is a perfect example of that. It's innovative,
Yeah.
it's insightful, and it really challenges us to think differently about
Mhm.
how we design and train AI models.
It reminds us that the future of AI isn't just about bigger and more powerful models,
Okay.
but about smarter, more efficient ones as well.
Well, I think that's a perfect note to end on.
Thank you.
This has been a truly insightful deep dive into the world of token budget aware LLM reasoning.
It's been a pleasure exploring this research with you.
Thanks for joining us on the deep dive. We hope you found this episode as thought-provoking as we did.
Yes.
Until next time, keep exploring, keep learning, and keep diving deep.